Hey everyone, my name's Steve, the host of your technology coach. Thank you for joining us on this fourth installment of the Snaptricity Arcade STEM Kit. In this lesson, we're going to be installing our first LED microprocessor, which includes a game selector that we can play up to 21 games. Along with that, we're going to be installing our first transistor, and we're going to tell you about what that does, and we're finally going to add some sound. So let's get started. This project is project number 17. It is called the game selector. So if you're familiar with how selectors work, whether it's an arcade game, some kind of digital menu, that's what this LED microcontroller is going to do for us. Now, I'm going to bring up on the screen here what the actual internals look like of this microcontroller. So in essence, it's kind of a mini computer. There are things in here and coding in here that is beyond what our STEM activities will do here, but it is definitely something to look forward to in the future. If this is something you endeavor to do in your career, then microcomputer electronics is definitely where this starts. All right, so we're also going to introduce a couple things to this as well. We're going to put a speaker in place, and then on project 19 in this same lesson, we're going to introduce what we call a transistor. Now this one here is what we call a PNP transistor. We're just going to set this aside for now. So we have that ready to go. And we're going to pick up our speaker. So we have this ready to go as well. We've already got our battery pack in place, which is our 4.5 volt battery pack, our LED microcontroller, and we need one more thing. We need to pick up our slider switch. So let's grab this because we need an on-off switch to control the flow of electrons. All right, so the first thing we're going to do is we're going to put our switch in place. Again, this is our electron flow. So we want to make sure that that is in the off position as we're starting to build, just for safety purposes and protecting ourselves and protecting the components. We want to turn that on when we're ready to turn it on. So I also want to introduce one more part that I almost forgot, and that is the selector switches themselves. So this is an ABC selector, and this is going to go onto the side portion here, what we call the inputs of the microcontroller. So if you notice, there's a lot of different terminals all the way around here. Again, we're not going to get to play with all these, but all these different terminals have a function. They could be inputs, they can be outputs, but for the most part on this side, these are inputs because they're going to look for input from our selector switch. All right, and I'm going to bring it up on screen one more time so you can see the actual internals of what this looks like from the inside. You can notice there's a lot of different wires and components in what we call a schematic. This is what you would design before you actually produced the product. Schematics are always like going back to the drawing board per se. So this is the drawing board. So when a designer, electronic engineer takes the design work, he gives it to a production person or even a testing person, engineer. They take what's on that paper, on that design, and they add all the components and they put the thing together. They test it, and once it passes all the tests, they send it to production, and then it can become a full-blown consumer product for us to play with and use. All right, little backstory on how these actually get from design to the table that we're at right now. All right, let's add another component. We're going to put our other number 3 in here. We need a conductor to go right there. We're going to grab our speaker. We're going to put that in place right now. Again, you want to make sure that you're aligning with the coordinates on the board as best possible, because they're going to help you determine where to lay things out and how deep to lay them out as well. So this one here has to go in a certain position, and it's going to go in that spot there because I need to grab a number 2 and connect that. If you notice on the schematic, there are areas that look like little hops across other lines and circuits on that design. That's because those hops indicate something that's not connected. And so not everything that is on the schematic is connected to each other. So we have to make sure we know what not to connect and what to connect. So for example, I need a riser right here because this area over here gets a bit tricky, because on this side here, you notice we have a difference in height. All right, so we're going to need to add a little riser here, and on the schematic you can see there's levels assigned. So there's a number 2 or a number 1 next to the component. That means it's a level 2 or on the circuit board itself. So we go by level 1, level 2, and then level 3 is above that. So if we were to take the next component right here, our little conductor, and we put this in place, you can see on the schematic it's a level 3. All right, so 1, 2, 3 is right there. Also, if you notice below it here, I needed to put another conductor underneath, which I failed to do. So we're going to do it right now. This has to go from here. See what I said? If you don't watch, you end up having to tear things apart again, which you don't want to do. So that has to connect to here. So that's a level 1. This is level 2. This is level 3. Okay, I told you, I practiced this, and they even got it wrong there. So just goes to show you, you can always improve and learn from your mistakes, right? Awesome. All right, we're going to the next level now, which is going to be our number 5. All right, so our number 5 is also going to require a riser. So we're going to connect that in place right there for the moment. This number 2 is going to go on top of our switch, and we're going to need another number 1 to put the riser in place, right? So we need to put that. If you notice on the schematic, it says level 1. It's a black number 1 there. That's going to go on the bottom. That goes next, and that on top. Oh, look at that. Pop. That was a pop, not a snap circuit. All right, sorry, bad dad joke. Move on. All right, now we're connected. So you can just see the different levels there, all the way around the board. Okay? And again, on the schematic, you're going to notice the way things appear to be connected are physically connected. You'll see the conductors coming together. Where it's not connected, you'll see hops of those lines going over the top. So we are ready to turn it on and add some power and see what we can get out of this, our game selector project. So here we go. All right, good news is we have LEDs, we have lights. These are again called light emitting diodes. So let's start the game. In this one, this is project number 18. It's just on the next page. It's called Lucky Doubles. The goal of this game is to hit a series of buttons and land on a double. All right, so the microcontroller is paired with the selector in order to do the functions we need it to do. I'm going to select A, 2, 3, and 4. So if you notice, each time I hit the A button, it increased the ones position by 1. If I hit the C button, it increases the tens position by 1. So that's how we can select what we're looking for, in our menu system. Now, I'm going to reset this by just removing power and reapplying the power. And I want to select game number 4. All right, game number 4 is called Lucky Doubles. This is going to be kind of like the electronic dice rolling game. And we're going to hit the B button in order to activate that game. So now the code in the game is now working. It's now ready to interact with us. All right. So what we're going to do is we're going to hold down the C button because it's saying go. If you can't read that, it's as close to go as an LED can. All right, we're gonna hold this down. That's not a double. Not a double. And the longer you hold it down, the input in that selector will continue to go. As soon as I release it, it stops. I never was good at card games, dice games, but there, hey, we got a double, 22. Now you heard the sound happen, all right? So again, the coding inside there, told that system, the microcontroller, that when you hit a double, you play the sound, all right? Let's try it one more time. All right, we're going to wrap that up, and we're gonna move to project number 19, where we're gonna introduce our transistor to this mix. All right, this is project number 19, and you may have noticed already, I've made several changes to this configuration. I've removed some components from the top. I have removed some other side components, and the risers have come off. And we've got these jumper cables available now. So we're going to talk about what those mean. But most importantly, we now have our transistor in place. Now this is called a PNP transistor. And there's many applications that we can use a transistor for, but in essence, we're using this as an amplifier. You can use them as electronic switches, which again will turn off or turn on a voltage depending on how the power is applied to the component. So in this particular transistor, like I said, it's a PNP. There's another type called NPN. We're not going to talk about the differences specifically, but all you need to know is that the material inside is what we call semiconductors, and they have special principles applied to them that are going to act a certain way. So there are three parts to the transistor. First, we have the base, we have the emitter, and we have the collector. So the way a transistor will function is when electricity is applied to the base, it will activate the emitter and collector and allow electrons to pass through them. The more current we apply to the base, the more potential current will start flowing through the collector and the emitter. Okay, so in this scenario, we can look at a transistor the same way we would look at a water faucet. So we have the base, the collector, and the emitter. So with the base on a transistor is the same as a flow control system in a water faucet. So if I apply electrical signal to the base, just like I would adjust the faucet flow using the lever here, I start to get a flow of water, or in a transistor's case, electrons, through the emitter from the collector. The more voltage I apply to the base, the more flow I have across the collector and the emitter. When I remove signal from the base, it stops the flow from the collector to the emitter. So let's put this together and see what we get out of this. So I'm going to put the speaker onto the emitter side, and I'm putting the conduit here, or the connector, onto the collector side. Again, this is our potential energy coming here. And then we have a jumper wire again, we've used these before, going onto the base. All right, so let's go ahead and power this up. And here we go. So we're going to select, on this project 19, we're going to select number 5, game number 5, which is called Lucky Sixes, Unlucky Ones. In this game, if you get sixes, you'll hear a celebration tone. If you get double ones, you're going to hear a failure tone, all right, or a losing tone. So we're going to select this using our B selector. It's going to tell us that we're ready to go. And we're going to hold down to C and see what happens. 21. Oh! All right, so there's the double ones we didn't want, so that's an elimination round right there, okay? So we're gonna keep going and see if we can get the double sixes. And there we go. So I'm going to end with that win, since I could go on for a while playing this game. But I hope you understand the lesson today and what we've done using the LED microprocessor. And if you noticed in that last round, we did hear, basically because of the amplifier, the sound was a lot louder than it was in the previous project. All right, well, this was lesson number 4 on the Snaptricity Arcade STEM Kit. I hope you enjoyed this. I hope you learned something from this with the transistors and the microprocessors and how it's all going to fit together into our final project. So stay tuned. In the next series, we're going to be really coming to the conclusion of all this, so we have one massive project all working together. Please like and subscribe to this, and we will see you in the next video.